All right, so I want to look at Chapter 6, Section 5 with the central. So this says assume that women's heights are normally distributed. So soon as you see this, you should be drawing a normal curve. And as you can see, I don't draw very well, so I'm going to have a template here in a second. With a mean given by 62.5 inches and a standard deviation of 1.6 inches. If one woman is randomly selected, find the probability that her height is less than 63 inches. So what you should do, and you should put the information that they give you, the mean right down the middle, 62.5, and then we're looking at less than, so it's going to be 63 inches or less, and that's important to understand how to read the table. So the table that I'm implying is you have to find a z statistic, which is found by taking the x value that you're interested in minus the mean divided by the standard deviation. So we just start plugging things in. Our x value is 63, the mean is 62.5, and the standard deviation was 1.6, and I get this value that I'm always going to round to 2 decimal places, because you'll see why, that's how you read the table. And this is the value that I'm looking up in my table. So what this number is it's the standardize, if I standardize this curve to a mean of 0, that's what standardization means, then this is saying I'm 0.31 standard deviations above, because it's positive, the mean. So this is a standard deviation, so we go to this standardized table and so in my formula sheet, I find the positive z-scores, because 0.31 is positive. I look for 0.3 and then under 0.1, and I get 0.6217, which would be my probability. All right, so moving right along, if I go the next part, so this is the same example. Now it says 40 women are selected. So the only thing that actually changes is when you have a sample size, your formula changes a little bit, because now we take the standard deviation and we divide it by the square root of our sample size. So that's the only part that changes. So you still put all this in your calculator, 63 minus 62.5 over 1.6, and then the square root of 40. And be careful that you're putting parentheses around this stuff in your calculator, and you should get 1.98. So you can see that with a sample, in this case, sample of 40, we're getting a larger standard deviation, which would make sense. That's the whole deal of that central limit theorem, is as our sample size gets larger, we have more data, and of course we can see we're going to get a smaller standard. So I go to my table, I'm looking for 1.98, there's 1.9, I look below until I get, went too far, until I get under 0.08, and it looks like that's going to be 0.9761, that intersection. So that's the probability that we would select, given this sample size, that we would select a woman 63 inches or smaller. Gist of all of these. The only tricks are those examples were a less than. These examples are a greater than, which says we need to learn how to read the table when we have a greater than. So let's look at this. It says the overhead reach distance of an adult female are normally distributed, drawing my normal curve. I have a mean of 195 and a standard deviation of 8.9. Here I want to find the probability the individual distance is greater than, and that's important. My picture, and they give me 195 and I'm looking for greater than 208.40. So I'm actually looking this way now. Your table, the way it's designed, it only gives you these probabilities. However, remember this is a probability curve and the entire curve adds up to 1. So if I wanted to find a greater than, all I have to do is find this value and do 1 minus the lower value. So that's what I'm going to do. I'm going to set up my z. This I get the same way every time. So 208.40 minus 195 over 8.9, and I get 1.51. So that's what I'm going to look up in the table, the 1.4. Away I go, 1.5 and then 1.51. But remember, I have to take 1 minus this value, because really what that probability is would be that you would get less than the 208.40. So I take 1 minus and get my nice little calculator out, and I get that for my answer. We have a sample size, so this one has a sample size. So I'm still going to do my same z. They changed my number on me here, so 193.7 minus 195. My standard deviation, when I have a sample size, don't forget to do the square root. And in this case, I got negative 0.57. Okay, so you're putting all that in your calculator, getting negative 0.57, which would make sense. It should be negative because this value is below the mean. And that's important to note, that you understand when you're getting answers, do they seem like they're right? Well, if the mean is 195 and we're looking at 193.7 or above, if I'm to the left of the mean, I should get a negative number. So again, my z was negative 0.5. Notice that's a negative, so I now have to actually grab the negative side of my table. And let's see if I can find 7, and I get 0.2843, but please don't forget, that's the probability it would be less than. So greater than, I need to do my 1 minus, and I get 0.7157. All right, so, but they're pretty straightforward once you can figure out how to read the table, because you're always just using that z formula, and the only time you change that formula is if they, out here it even says, so we say a normal distribution can be used if our sample size is greater than 30 or greater, but the problem is that last one had a sample size of 15. Notice it told me my population was normally distributed. And that's why I could use my normal distribution, meaning my z-table. All right, last example. This is a probability between. So what we've done so far, we had a probability below, we had a probability above, but now we want to look at what if we're between two values and we want to find that probability in between. So let's see, it says if a woman is randomly selected, find the probability that her height is between 63.8 and 64.8, given that we have a mean of 64.1 and a standard deviation of. So let's draw what I know. I know I have 64.1 is my mean. I'm looking at between 63.8, it'd be to the left because it's lower, and then 64.8, which would be to the right because it's higher. So this is the probability that I'm looking for. All right, let's think about this. If I could find this probability, the upper, and then find the lower probability, if I subtracted those two values, it would give me the in-between. So that's what I'm going to do. I call it the lower. So the 63.8 minus the mean over my standard deviation, and I get negative 0.14. And then I call the upper the 64.8 minus 64.1 over 2.1, and I get 0.33. So I actually have two different z values. Again, a negative makes sense because it's below. Positive makes sense, it's above. So I look both of these, negative 0.14. So where's my 0.04? Looks to be that value right there, 0.4443. And one, which was 0.33. Where are we at here? Right there. And I get 0.6293. So I want to take the higher one and subtract the lower one, and that gives me my middle probability. So that's the key with these. How do you find the probability below? That's the easiest one, right? You just flat out read the table. How do you find the probability greater than? That's where you have to do the 1 minus. And then how do you find the probability between? That's how you have a upper and a lower, and you subtract the two values.